Hello, folks. So, the topic of the third session is evolution of testing functions, a front row view. And today, the session will be taken by Naman Kapoor. And who's Naman Kapoor? Naman has nearly 13 years of experience with over 5 years at Google and he has worked previously at Apple and Amazon. He began at Global Logic before joining Polycom. He enjoys teaching and mentoring software developers and testers, and having guided many professionals on quality improvement from different perspective. I would love to call up on the stage Naman.
Hello everyone. Let me quickly start the screen share as well. So I hope everyone is able to see my screen.
Yes.
Again, can you type one, please? Wow, great, great to have the enthusiasm and attentive set of audience, right? So today we are going to talk about, like as said in the introduction, I do a lot of teaching. I do a lot of mentoring. And one of the questions that is on top of everyone's mind today is is AI going to take my job? And especially in the function of teaching, in the function of testing, right? People are so much worried, like, is AI going to do this? Is AI going to be able to do this? Or where am I? What should I do? How should I prepare for the future? So here I am trying to address the elephant in everyone's mind, in everyone's job set, right? To give you a sense of where we might be going with AI, where we might be going with the evolution of testing, and how the future might look like. What might AI be able to do really? And what might AI not be able to do, where we can focus on our energies, right? If AI is not able to do something, let's do it as in testers. Okay. So now to start with, I have quantified some of the very basic attributes of SDET and QAs. Okay, how people in the industry see QAs and SDET. So QAs, most of the time they refer to manual testers. Okay, uh, again, all of this is true for 90% of the people. Nothing is true for 100%. So bear it with a pinch of salt. Okay. So QAs, by and large, should have some skills. They should be able to write test strategy. They should be able to write test cases, test plan, do assumptions, take out what needs to be tested, find out the critical user journeys, then executing automation, performing and use being able to use tools like Postman for RESTful API testing, or maybe some dedicated tools for individual areas, maybe some automation framework which you have in house. All those kind of things they should be able to use. That is a very basic outline of what QAs are today, about how QA role is seen today. Okay. Coming to the next role is called SDET, which stands for Software Development Engineer Test. So SDETs are supposed to have all the skills of QAs, which we just talked about. Along with that, they should know at least one programming language, should be have a very good knowledge in at least one program automation tool, may it be Selenium, Cypress, RESTful API testing, JMeter, APM, whatever you name it. Like the list goes on and on and on. Okay, and should be able to write automation. These are the basic attributes. If we go towards the advanced state kinds or kind of things, then they should be able to develop some frameworks, should have knowledge about CI/CD pipeline setup. How is that done? Some cloud technologies or SQL, or some job function specific skills. For example, Salesforce. For example, if you are doing protocol testing, then knowledge of that protocol, things like that. Okay, so this is what, by and large, what QAs and SDETs have been doing in this era. Okay, pre AI, these are what are the roles and responsibilities of SDET and QA. Now the big question: which of these tasks will AI be able to do? And hold your seat belts for the answer. 90% of whatever you have seen, AI will be able to do. Yes, you heard it right. 90% of whatever you are seeing on the slide one, AI will be able to do. AI will be able to write test plan, test strategy, test cases. They will write fantastic critical user journeys. Some of them which you might be missing, AI will be able to write even those. Okay. Uh, Rest apart, like you leave the manual testing, they will AI will be able to carry out most of it. From the automation front, they will be able to write the automation as well. Okay, you give a CUJ, they will do the automation. And that is not something that I am just saying for the sake of it. It is going to happen. Okay, just think of it on the lines, like if you have like 15 automation test cases written in one framework and you have to write the 16th one, how do you generally write? The steps are, you find out a closest one, something that is working on that same page, something that has already navigated to the same page, copy that piece or modularize it. If you are more into ethical practices, you modularize the code, and then you do add certain steps, remove certain steps, and that's it. AI will easily be able to do those things. Leave apart those, they will even be able to write new test cases from scratch. Okay, so most of the attributes that you are seeing, AI is going to take up. Now, this calls for a alarm, some tension in the room. Okay, if AI is going to take up everything, where will I be? What will happen to the role of SDET? So now to answer that, let us focus on the long forgotten fundamentals of testing. Today, what happens when we say of testing, for example, if I have taken an example of automating Google search. So if I ask anyone how will you automate Google search, most of them will start like, I'll call function, like I will go to the UI, input X, expect Y kind of thing. Okay, some might even go to the API layer, say that I'll input this and expect the output this. But if you look at things in deep, that is not how you can automate anything like Google search. Okay. So let's get to the testing fundamentals on how we should have been doing testing. And this is true for most of the product, and this is what most of the man companies are following. They are not only following from now, they are following from even before. Okay. They follow this to their core, the whatever I am going to tell. Okay. So the first fundamental skill is called pyramid of testing. What does pyramid of testing say? So what does pyramid of testing do is it categorizes test into different categories. Okay, it says that the spread of how much we can test using different kind of testing, which basically means unit test, integration test, and end-to-end test. How much we should be testing using each of these layers is that around 70 to 80% of our testing should be done at unit testing layer. Another 15 to 20% should be done at the integration testing layer. Another 5% maximum should only be end-to-end testing. Yes, you heard it right. Only 5% of the testing should be end-to-end. Now think back, like 2 minutes back. What were we talking about? How do you test Google search? Input A and expect B output. This is what? This is end-to-end testing. But pyramid of testing is saying no, this is not something that has come up after AI, right? I did my BTech like 13 years back, and I remember seeing pyramid of testing in one of my textbooks. I don't recall which textbook, where, but it was taught to me. What is pyramid of testing? I did not get a word of it at that time. I'll not lie. I did not understand anything. What is this pyramid of testing? I just studied it, passed it. If it was asked in exam, I wrote it. But today it has become one of the most important parameters. That pyramid of testing says that unit testing should be doing maximum amount of testing, followed by integration and followed by end-to-end. End-to-end should only be 5 to 7, 10%. That's it maximum. Now, why? What is the reason? Why should so? What argument people give is that we should always be testing like the end user does, which is not a very good argument. Okay, the end, it is, at one point it is a very good argument, and on the other side it is not a, it is most the one of the most lame arguments. Okay, why it is very good? When we say we should be testing like a end user does critical user journeys, right? CUJs. That is what should come at the end to end testing layer. Why is it lame? Because we have understood it like every testing that should happen should only happen from the end to end layer, which is not correct. Okay, critical user journey means that you are automating what a user will do when he comes to your platform in practical. Okay, now what are the reasons? Why does pyramid of testing say all of this? It says so because unit tests are the ones which are very stable. Okay, they don't fail, and if they fail, the what the developer thinks is that I have introduced a bug. They don't think that okay, the test might have failed and it might be flaky or something like that, right? They run very fast. They run in milliseconds. They give you a very high confidence in whatever part you are building, whatever part you touch. If the unit tests are passing, you are very good. Okay, if you have a very good unit test coverage and you find out that the tests are passing, you will feel as a developer very confident. End-to-end tests are good for none of these reasons. End-to-end tests are good to give you a confidence in the entire system. Yes, if a user comes to Gmail, they will be able to sign in, they will be able to read the mails, they will be able to, reply to a couple of mails, delete a couple of mails, and do all of those transactions. Okay, so that is what end-to-end testing was for, and that's what pyramid of testing says. In the slides to come, you will understand more about it, why we talked about pyramid of testing. The next testing fundamental that comes up is hermetic testing. So hermetic testing is like, it means that I want to test my module. Okay, now to think of this like, suppose you are working on a library A. The library A depends upon library B, C, D, E. Okay, now when you are doing the testing, you should be worried only about, is library A working fine? That's it. You don't need to find out that there has been, library B is doing this thing or library C is doing this thing. Okay, if I am a developer, I am making changes in library A. I only want to know, is library A working fine? I don't want to deal with B, C, D, E, whatever distractions they are. Okay. This is what hermetic testing is. What hermetic testing says is that you isolate A from B, C, D, E. That means whatever transactions are going from A to B, create test mocks, test straight, test doubles, isolate your request responses. Okay, use a lot of fakes. Make sure that you have a specific response. What will this help you in? First thing, you will have a lot of confidence whether your code is working fine or not. Second thing, in general, projects are really huge. Okay, think of any huge project, maybe just like the entire backend of Uber. Okay, or entire backend of Netflix or entire backend of Google search. Can you bring any of those components entirely upon a single machine? The answer is no. It is not possible. It won't fit in. Okay, but if you think about the hermetic testing, what it will enable you to do is that now you don't, your component A does not worry about how is B doing, how is C doing, how is D doing. They don't care about. They only care about component A. When you have all the components fake, this component in itself is not very large. Okay, this can be brought up on maybe a medium-sized cloud machine. Okay, cloud instance, it can be brought up. So what this will enable you to do is, this will enable you to add pre-submit test. Okay, what is pre-submit test? Your developers will be able to test all the code even before they submit the code. Think of it. Today, when are we testing? We are testing when we are going for a release. That is like, if we have a monthly release cadence, we are releasing once a month, we are testing very much towards the end, right? What have we done instead? We have shifted left the entire process. Okay, that means my entire testing can now be done in the initial phase. Okay, the moment the developer is not even allowed to check in a bug, that's how you can call it. So that's the beauty of combination of shift left and hermetic testing. Okay, now hermetic building a hermetic stack is a technically challenging job. It's equivalent to being a developer. Okay, you do a lot of in-depth analysis of your system's architecture, how to make testable softwares, and all of those aspects. Okay, so that is what these two fundamentals talk about: hermetic testing and shift left. Okay, the next thing that comes is again very interesting, which has been there for a long time, but we never paid that much attention to it, which is quantitative versus qualitative testing. So, what does that mean? So, let us suppose we want to test what is 2 plus 2. The answer is 4. Okay, that is called qualitative. You have definitive answers for your testing. Okay, you are giving the input A, you expect the output B. That is how now this is how testing is done today. Okay, we have expected output, we assert the actual output again the expected output, and then we pass or fail our test. Okay, but think about this, like how will you test a AI driven, let's say, chat GPT or Gemini? All right, you give out one query, it will give you new answers every time you hit enter. Now this is called qualitative testing. Okay, some other examples of qualitative testing that has been around you, but you might not have thought about it. Something like Google search or any search engine. Take that for example, Google, Bing, whatever you want to use. Uh, they give you the first 10 results are dependent upon so many factors, right? So let's take an example. You are searching for Sachin. Okay, now Sachin, there could be, let's say, 5,000 pages. It is the qualitative side of thing which tells that, okay, out of these 5,000 pages, these 10 pages should be on the top. Okay, that is quality. Okay, that is not quantity, that is quality. You are seeing 10 results, that is quantity. You are seeing the best of 10 results is quality. So qualitative testing is the next fundamental. How do you do qualitative testing? Okay, and the last skill that comes up is system design. Now, this is something which I have seen many of the test engineers and SDETs. They do not care much about it. Okay, even if they care, they will care in terms of boxes. Okay, we have a server A that talks to server B, maybe it talks to server C, and blah blah blah. That is how our flow is basically working, and that's it, right? That becomes the system architecture. But think of the line, like how are you going to make a software testable if you are following all these fundamentals? If you are following hermetic testing, you want to test all everything in the unit testing layer. If you want to carry out all those things, how are you going to do it without system design? Okay, so basically let's take again a very crude example. People say that they want to do performance testing. Now you ask many of the folks, like, how will you do performance testing? I will send X number of requests per second to my server and make sure that what is the time that it is returning the request. What happens when you have a cache? What is cache? Cache is an in-memory database. Okay, now if your results are coming from cache, your your response time is going to be much less. However, if your requests are going to come from the actual database, actual business logic, your response time is going to be quite huge. Okay, comparatively, there is going to be the difference. Now, how do you catch these kind of issues? How do you think of that system design aspect, that I have a cache in between? Or do you think about the how load balancers would work? Do you think about the failover testing that we might be doing? So one of the interesting things that I learned in some of the big companies is that they do a production failover testing. How will my system behave if the production server crashes? Okay, that is, did we think about it? There have been instances when companies did not test rollouts, rollbacks, and they found that when they encountered a problem, they found that okay, all our data that we were backing up so with such a huge confidence is corrupt. And this is not something that I'm making up. This has happened in past. Okay, so why is it important for test engineers to know system design? We do not need to emphasize more. If you know system design, then being a test engineer, you will be able to test the aspects of software which others might not be able to pick up. And that is how testing should have been done, right? So now with these fundamentals, let us take the example of, again, let's take the example of how we will answer the same question which we addressed in the beginning. How will you test Google search? Okay. How will we answer these using all the skills that we just mentioned? Okay. So let's say there is a request that comes, it will go to API server. Now I'm drawing out a high level architecture diagram. Okay. If you're working in your company, you will have access to a very low level architecture diagram as well, which you can utilize. But let's for now take a look at a high level architecture and how we should be doing testing. Okay. A request comes to API server, a search request. There will be filter or modifiers that will act on that request. What is their job? Their job will be that remove the stop words is and the these are not searched by any search engine. Okay, so remove all those, put a logical weight to the numbers, prepare n grams of the numbers of the input query. All those things you do. Then you do a search server. Now that search server will basically try to search from the cache. Okay, if it gets the result, well and good. If it doesn't get the result, it is going to search for the inverted index database. Now, what is an inverted index database? Search works like, if I am saying, hi, this is Naman, it will pick up hi is stored in document one, position word number one. Naman is stored in document one, word number five, something like that. It will store the inverted index. Once your query comes for Naman, it becomes like searching in a hash map. Okay, it is just key value pairs. Okay, where the values are basically linked list, which contains where all Naman is there. That is called an inverted index database. Now the search server will search from the inverted index database. It will go back, send the result to a ranking system, which will again try to find out what 10 results should we show for the query, and then the response will flow. Now the question comes, where is the data coming into the inverted index database? What will happen is that there will be a web crawler, which will crawl the internet, fill the and keep on feeding the results into, after filtering, it will keep on feeding the results into a database. There will be offline process which will convert this database into inverted index. Something like that is how a search should work. This is in generic for any search. Most of the search work in this way. Okay. So now if you know this architecture, okay, how will you test? You will test each block by block. Okay, how will I test the, let's say I want to test the rank brain. Now rank brain will have different parameters. It will should be able to tell which results should be on top. Okay, so I can give dummy inputs which are which are definable, and my rank brain also, I should be able to give the parameters on which my rank brain should order these results, and they should give out the number, give out a score to each of the result. Okay, how will I test my cache? How will I test my inverted index database? You think about each component. Now each of these component, if you look at a search product, probably thousands of engineers will be working on it. Okay, you just you draw a block around what module you are going to work on. Okay, If you are going to work on, let's say, a offline processing job, your job should be, your first focus should be that I want to test my block. You design the fakes for those. You design the, understand the architecture, design fakes, design testables, design everything that can help you staying in the box, and then you test that box individually. Okay, and once you have done that, you expand the scope. Okay, start. So ideally, what should happen is that your unit test should only test the method that it is focusing on. It should not test anything that can be, that can include flakiness, like calls to database, calls to uh, calls to multi-threading, or calls to file read, calls to another API. All of this should be removed, and then you should be doing all the testing. Okay. Now, if you are doing all these kind of, start to follow all these kind of testing practices, best practices, you feel that the role of SDET is not just sticking to these fundamentals, these skills what we saw. Okay, it is much broader than that. Okay, the horizon of being an estate is such a broad thing. Okay, and if you pick up these things, if you start to do that, what will happen, the future of estate will be that testing will be seen like, and this is happening today in many of the companies, there is not a difference in the salary between test engineers and developers. Okay, they are paid the same. They can switch, even like from a SDET role, you can directly switch to a development role full time without interviews, without anything, and vice versa. Also, you can do. There is no nothing is stopping you from doing that. Okay, they are seen like developers. Okay, now the next thing that will happen is that a lot of focus will shift from quantitative testing to qualitative testing. Think on the lines of like, how will you test the AI models that you are deploying? Many of the products are using AI models, right? Now AI, when you combine ML AI models and all of those things, they are capable of learning in the fly, right? They are capable of learning in production. How do you monitor that it is learning the right things? The graph is going up, it's not going down. How do you monitor those things? That should be a job of an estate, right? So start thinking in terms of qualitative testing. That is going to be the harder one. Okay. Next thing that definitely will be coming to the estates is designing of hermetic stack, code bases, designing of the testables, and all of those will be part of estate roles in future. Okay. uh, Next, the like one of the things that is going to, it is still there today also, it is there in many of the companies, but this skill is going to take even more precedence. That is the analytical skills. Okay, analyzing that my production bugs are going up, the number of production bugs are going up, finding out the reason for why my product number of production bugs are going up, right? And assisting developers in designing better products. All of those are going to be the roles of SDETs in future. These are already, as I have already iterated, these are already the expectations from many of the companies at present also. They have switched their expectations. Okay. So if you are an SDET who is looking for a ride in the future, you should focus on some of the different skills. Like, you should be very strong in coding skills. You should have very good system design skills. You should be able to think on the line, how do I develop a testable software? Okay. Yeah. Then capability of developing new tools. I'm not talking about framework. I'm talking about new tools. So think on the lines like, have were we all aware? Of course, AI is there for decades now, but were we all aware of AI before this boom? The answer is no, right? We didn't knew. Same way, what is going to happen is, so now AI is something very new. Do we have testing enough testing tools for that? No, we don't have. Probably the world needs at present a lot of tool development. Okay. And lastly, but not the least, a good knowledge of AI and using them on testing related platforms and testing related fundamentals and all those things. So that is what is going to be the future of SDETs. So now we need to buckle up ourselves to get a ride in the future. This is a good time to upscale. Okay. And I don't think people should fear from it because upscaling has been the process throughout the journey of software engineers. Okay, everyone has been upscaling, right? Just think of it. If I give you a thought that you know what, you learn Selenium, you learn Java, you learn APM, and for next 30 years you will be able to eat out of it. What will you say? Yeah, like, oh, are you out of your mind? I learned three things and now I'll be able to eat out of it for the rest of my life, right? That is not going to happen. So you have to upscale in the 30-year long career, 30, 35 year, whatever is your career duration left, you have to upskill. And you cannot just say that I have a handful of skills and now this is going to drive the entire future. No, that is not going to happen. So open up your minds, and these are the skills that you should be focusing on. We all should be focusing on as athletes. After all, like, SDET stands for software development engineer. It has a development word. Okay, many companies like I I see that companies like Amazon, like you see software development engineer, Android, iOS, this, that, back and front end. There are so many roles. Okay, what does any of the role mean? Software development Android means I am a developer. My expertise is in building Android application. SD iOS means I'm a developer. My expertise is in building iOS application. So what should SDET mean? I am a developer. I'm not going to, probably it is not right to expect that a core skill of SDET should be that I can just write 5, 10 scripts. I am a developer, and my expertise is in testing. How should I test a software? Okay, so with that in mind, that should be the focus of the future. And with that, we come to an end. I will love to take any questions which you might have.
That is amazing. I think I was reading lots of comments in the chat section, and people were praising you over the whole session. Perfect, folks. I'll request everyone to please upvote your questions. Okay, I can see lots and lots of questions, but I'll only be able to take three questions at max. Okay, like I said between during the session that Naman is part of the Discord community. Please ask questions in the community. I'll make sure Naman gets to know about all those questions.
Yeah, sure. Although like I'm very limited. I do not, as a person, I do not, I'm not active on any social media platform.
Yeah,
I'm only active on LinkedIn. That's it. I do not. I'm not there. But yeah, if there
yeah,
are questions on Discord,
yeah,
I'll be happy to answer them.
yeah. Perfect. The most upvoted question on the stage currently: how Google, Amazon uses AI in testing?
Okay, it's not right to. I mean, see, there are different confidentiality clause also, right? I mean, it is wrong to say that Amazon is doing this, if I or Google is doing this, and even if I am going to say something, it will be those things which are already out. Okay, so but by and large, don't go with companies, go with fundamentals. Okay, if we have ever given a interview of one of the FANG companies, you would have realized they are not asking anything. They are only focusing on very basic things like data structures. They ask it in a blown out way, which is very fundamental. Like data structures has been there for like 40, 50, whatever number of years we all can imagine. Like software engineering has been, data structure has been there. Okay, similarly system design, they ask system design. System design has been a part of software culture throughout eternity. Okay, they are asking questions related to the very basics of testing. How will you test XYZ scenario application? They are not asking you how will you click on the calendar icon using Selenium, Cypress, or how will you select a date, how will you do a drop down. No, why? Probably that's the reason, right? We do not. So if you want to truly understand what is going behind these companies, think on the very basics. Okay, I cannot, probably I have confidentiality clause, I cannot give you out a lot of details, but yeah, this is where I will be hinting you to think on the basics. They are only focusing on basics. We have a lot of testing that is done in using hermetic stacks. We have a lot of testing that is done using a lot of unit test coverages and all of those things. Okay.
Perfect. Next question on the stage is how to get job in Google, Microsoft, or Amazon as a QA.
Okay. Similar answer. You do a practice. So there are two parts to the job. Okay. First is a resume, that your resume gets selected. Second is that you are able to clear the interview. And rather, there is a third part also, but I'll not answer the third part, that you are able to sustain that job, right? You just don't want to get in and get fired. Okay. So there are three parts to the thing. I'll leave the third part. The first part is how will my resume get selected. So see what happens in any of these companies is that they get a lot of resumes, probably thousands of resumes. Okay, for each job opening. Now they have, obviously we all know about ATS scores. They will be using ATS scores, but that's not all, right? You need to add a lot of weight to your resume. You can do it in terms of showing open source contribution. You can show it by telling the quality of work that you are doing. Think on the lines like there are two stages for resume screening. First is that you get a ATS score and you get listed in the top applicants. The second is that some human is going to read your resume. Now, every SDET or quality engineer or test engineer would have written test plan, test strategy, test cases, would have written the similar kind of things, right? Would have done some tools, some automation kind of thing. What makes you stand out?
Yeah,
Think on that line. Okay.
perfect.
Once you think, then you will be able to clear the resume. Then the second part is like clearing the interview. So interview, as I already talked about, you need to focus on the basics.
Awesome. Folks, because of the time, I'll only be able to take one more question. The question is, in the era of AI-driven testing, how do you envision SDET evolving beyond traditional roles to become champions of qualitative testing, including addressing biases in AI models? What concrete steps can SDET take to stay ahead of these transformations?
The best concrete step that you can take as an SDET is learn AI. Okay. That is the best thing that you can do. Focus on the basics, focus on the newer technologies. Think of the lines that everyone in the software industry is getting a job because there is someone to develop. There is a developer, so a tester works, a manager works, a product manager works, program manager works, everyone, because there is a developer at the center. The more you want to get better at either of these roles, the more you should learn into development. Okay. Don't shy away that I am a tester, why do I need to learn? No, that is not how it is going to be. You need to learn developmental skills. You should be passionate about testing. You learn AI skills. Once you know the skills, you know the capabilities, that you know the power that it can bring. Now you can incorporate those powers into your day-to-day job. Okay. You know what the things are capable of. Employ those in your day-to-day challenges that you're seeing, and that's how you can grow and stay ahead.
Perfect. Perfect. That was an amazing answer. Thank you. Thank you very much, Naman, for doing this session. I think everyone loved your session. Yeah.
Thank you everyone for your time, and
Thank you
it
very
was
much,
nice
Naman.
having a lovely audience.
Yeah.
Thank you.